Hello everyone, my name is Wilbert Lancelot S. Aguilar, and today I want to share my reflections on a journey through the development of the GPU, how it became central to AI and computing, and where I believe we're heading in a future shaped by digital twins, metaverse, autonomous vehicles, and more. Let's start with the GPU itself. In the early days, GPUs were purely graphic accelerator, specialized chip designed for rendering, for graphics, and for gaming. Their architecture was built for parallelism because graphics inherently involve a lot of independent, simultaneous calculations. As John Peddy notes, GPUs have gone through distinct eras, evolving from fixed function graphics hardware to fully programmable, general purpose parallel processors. Over time, they became more than just for gaming. The advent of CUDA, introduced by NVIDIA, was turning point. It allowed engineers and scientists to use GPUs for general computation. Architecturally, GPUs evolved rapidly from microarchitectures like Tesla to Volta, and Maxwell, Pascal, Turing, Ampere, and now newer generations. Each generations pushing performance, efficiency, and parallelism. There is also a concept popularly called Huang's Law, named after NVIDIA's CEO Jensen Huang. The idea that GPU performance more than doubles every 2 years, even faster than classical Moore's law for CPUs. The history is not just technical, it's a story of how an engineer component designed for a very specific purpose was transformed into a universal compute engine. The GPU really became the unsung hero behind scientific computing, AI simulations, and more. GPU as the backbone of intelligent driving, autonomous vehicles. Moving to the second video, applications in intelligent driving vehicles. Autonomous driving requires massive computation power to process sensors, data, to run a real-time inference for perception, decision-making, and planning. GPUs are uniquely fit for this because of their parallel processing power, low latency, and high throughput. In self-driving cars, GPUs can power the neural networks that detect obstacles, recognize traffic signs, predict pedestrian movements, and more. They can also support simulations, training models in virtual environments before deploying on real roads. More broadly, the role of GPU in intelligent driving is not just during runtime. It is crucial during development, training neural networks, simulating edge cases, running data twin simulations of vehicles and its environment. To me, this is profound. The same technology that once rendered video game graphics is now helping us create safer, smarter vehicles that may remove human errors from driving. That shifts feels like what feels like one of the purest expressions of progress in engineering. Now, the third video asks, is all this future talk just hype? And where are we really going? Here are some of my reflections grounded in what I believe is real potential, but also mindful of challenges. 1. Digital twins. Digital twins are virtual replicas of physical systems, buildings, factories, even entire cities. These twins can be simulated in real life, allowing us to test, optimize, and predict before acting in the physical world. According to experts, digital twins are transforming industries like manufacturing and urban planning. Two is metaverse. The metaverse is often described as the next stage of the internet. Immersive, interactive, persistent, but it but to build it, we need enormous compute for rendering, for real-time interactions, for physics, for avatars and GPUs are central. NVIDIA, for example, has its Omniverse platform meant for collaborative 3D design, simulation, and virtual worlds. There are significant concerns however, about energy consumption. Some research into green metaverse networking warns that immersive metaverse technologies, digital twins, and related compute are energy hungry, where the hype might be real. Not everything is hype. With GPU development accelerating, considers architectures like Blackwell and the upcoming Rubin architecture targeting even more AI computer. Real progress is happening. These architectures may support ultra-long context AI, generative video, more efficient simulations, all things that could power advanced metaverses, experience, or very realistic digital twins. Now, reflecting personally, here are my hopes and aspirations and a dose of realism. The responsibility of power. With great computer power comes great responsibility. As future engineers, we'll need to prioritize not just performance, but sustainability. I believe one of our biggest tasks will be making sure GPU-driven technology serves humanity, not just serve as flashy demos. Bridging virtual and physical. I see a future where the boundary between the physical world and the virtual world blurs. Digital twins will not just be simulations, they will be decision engines. Real life, infrastructures, mobility system, and even governance could use virtual replicas to test and deploy policies before implementing them. That's powerful, but it also demands care. How do we ensure these digital representations are accurate, unbiased, and secure? AI plus metaverse plus autonomy. These three domains are not separate. The AI models that run in self-driving cars can be the same model that animate NPCs or avatars in the metaverse. Digital twin data can feed into AI for predictive analytics, and virtual worlds can simulate driving scenarios for training. The convergence is where huge value lies. To sum up, the GPU has dramatically transformed from a graphics accelerator to a general purpose compute workhorse, central to AI, simulation, and high performance computing. In autonomous driving, it is already a key enabler, powering perception, decision making, and simulations. Looking ahead, digital twins and the metaverse represents real opportunities, not just hype. But they come with immense challenge, especially around energy, ethics, and inclusivity. As future engineers and leaders, we have a role to guide this evolution responsibly, to harness GPU powers for real world good, and to ensure that the future we build is sustainable, equitable, and meaningful. I feel a deep sense of excitement, but also humility. We're standing at the remarkable moment in computing history. The tools are powerful, but how we wield them will define the future. That's both a privilege and a responsibility.